Alright, hey Algebra 1. Time to take a look at the first section we're going to cover today, which is factoring by the GCF. It's actually the most important method of factoring that we cover because it always needs to be done. Every single time you guys are going to do a factoring problem, you have to check to see if there's a GCF that could be factored out first, because a lot of times the problems become easier or actually solvable after the GCF is factored out. So first things first, what exactly is a GCF? Well, GCF stands for the greatest common factor. The greatest common factor. So that's the number that divides evenly into the two numbers we're looking at, or the two polynomials we're looking at, without going over. So obviously it has to be the largest one that fits in evenly, that doesn't go over. So you have to make sure you figure it out. So like, let's look at an example. What if I asked you guys what the GCF of 80 and 76 was? 80 and 76. So the best way to take a look at it is to break these down into factor trees. So this method is called prime factorization. We're going to break these down. So let's see, 80 can be broken down to 8 times 10. And then 8 can be broken down to 4 times 2. And 10 is 5 times 2. And I've got a prime here, a prime here, a prime here. And 4 times 4 is 2 times 2 rather is 4. So the prime factorization of 80 is 1, 2, 3, 4, 2 to the 4th times 5. Let's compare that to 76. All right, 76, let's see, what's that? 35, 38. 38 and 2, and 2 prime, and then let's break 38 down. Will that be 15, 19, and 2? And those are actually both prime. So the prime factorization of 76 is 2 squared times 19. So now you have to ask yourself, well, the greatest common factor is the largest possible number that is in common between the two. So let's take a look at comparing these things. So you got 2 to the 4th over here and 2 to the 2nd over here. So how many 2's could you pull out? All right, you could pull out 2 to the 2nd. So 2 to the 2nd. And then 5 is in the left term, but not in the right. And a 19 is in the right term, but not in the left. So you can't use that as part of your GCF. The GCF is simply just going to be 2 squared or 4. All right? So that's pretty much how you take the GCF of a number. Now let's go ahead and look at a polynomial. Well, here are a couple of monomials here, 4x cubed and 24x. The GCF of the number portion should be completed first. So let's ask ourselves, what's the GCF between 4 and 24? Now you may know it right off the bat because these numbers are fairly small, or you might have to break them down into factor trees, but the GCF of 4 and 24 is 4. Okay? And then you ask yourself, well, what's the GCF between x cubed and x to the first power? Well, you have to ask yourself the same question. The prime factorization of x cubed is just x times x times x. And the prime factorization of x to the first is just x. So how many could you take out from each one? The answer would just be x to the first power. All right, with variables, it's always the smallest exponent. Okay, it's a little tip for you. Smallest exponent is the GCF. So for example, you're looking at x to the 7 and x to the 9. What's the GCF between x to the 7th and x to the 9th? It's the smaller of the two exponents, x to the 7th. Okay, that would be the GCF in this example, GCF. All right, it's just a little helpful hint for you. Let's put it all together. Now what we're going to do is factor out the GCF that we just had in common. So for example, we just did this problem. We found the GCF was 4x, so we're going to factor it out. Factoring it out means writing it first alone, and then seeing what's left over after you factor it out. For example, 4x cubed, we're going to factor out a 4x. So you're going to do 4, and you're going to divide by 4, and that's just a 1 left over. And then you can do x cubed and divide that by x. Well, you had x to the 3rd, which is really like x times x times x. And you pulled out one of the x's, so if you pull one of them out, I just really crossed out an x. That didn't really help too much, did it? Let's just try to use a different color and just go like this. Cross out the x. What's left over? What's left over is x squared. Okay? And then we do the 24x term. Now, if you factor a 4 out of 24, that's just 6. We're using division. 24 divided by 4 is 6. And then x, we're going to factor out an x. Well, we only had one, and we pulled it out, so there's no more x's. This right here is that polynomial, 4x cubed plus 24x, in factored form. Now here's the neat thing about factoring. If you use the distributive property like we just learned in the last section, and multiply 4x by x squared and 4x by 6, you should in fact get the original polynomial. Well, let's check. 4x times x squared is just 4x to the third, plus 4x times 6 is 24x. And if you see, we did in fact get the original polynomial. So factoring is basically making the problems look like the questions you were just asked on the last assessment. So we're kind of going backwards in the reverse direction. Let's try another problem. Here's a good one. 25x squared minus 15x plus 10. Got to ask yourself, what is the GCF of all of the numbers first? So I've got a 25, I got a 15, and I got a 10. Well, it looks like 5 is going to be the largest number that divides evenly into them, and I can't pull a 10 out because of the 15 to 25, and then anything higher than 10 doesn't work because obviously 10 is not going to, any of those won't be factors of 10. So that's good, so it's going to be 5. And I got to look at the variables. I got x squared, x, and unfortunately no x's over here in this term. And remember, it's always the smallest exponent, so the x to the 0 would win. I can't pull any x's out. Then we factor. So if you take 25x squared and you divide it by 5, 25 divided by 5 is 5, x squared. Let's double check as we go just to make sure this is looking good. If I do 5 times 5x squared, that's 25x squared. Hooray! Let's keep going. Negative 15x divided by 5 would be negative 3x. Double check my math here. If I do the multiplication, 5 times negative 3x is negative 15x. And then I do one more. I do 10 divided by 5. That's just 2. So if I go and I use the distributive property here, 5 times 2, this would be plus 10. As you see, this matches up with the original polynomial, and my answer in factored form is this right here. Essentially what we're doing is we're making the answers look a little bit neater. We're taking the polynomials and then we're removing any common terms. Alright? Let's try a couple more. 12x squared minus 10x minus 4. Alright, so let's look at the number portions first. GCF of 12, 10, and 4. Unfortunately, you can't pull 4 out. It's just going to be 2 because 10 doesn't divide into 4, so it'll be 2. And then the variable portions, you got x squared, you got x, and you got nothing, so you can't pull any out. Then we factor. 12x squared divide 2 will just be 6x squared. 10x or negative 10x divide 2 will be negative 5x, and negative 4 divide 2 will be negative 2. Right, so that would be the factored answer there. Let's go try the bottom one. That looks like the same problem we just did. Oh, let's try something a little different. Alright, yeah, let's try that. Let's do this one right here. Let's get the page. Here we go. This will be the last one that we do. We got 32x cubed plus 100x squared plus 36x. So first you got to find the GCF of the number portions. This is where factor trees may come into play. 32, 100, and 36 all have something in common. What is it? Well, that's one you may need to make a factor tree for because it's not clear off the top of your head. So what I would do is make a factor tree. So 32 breaks down into 16 times 2, and 2's prime. And 16 is 4 times 4. And each of the 4's break down to 2 times 2. And all those 2's are prime. So 32 is 2 to the 1, 2, 3, 4, 5th power. So 2 to the 5th power. That's the prime factorization of 32. Let's compare that with 100. Now 100 is 10 times 10. And each of the 10's is 5 times 2. Or 2 times 5. And all those are prime. So the prime factorization of 100 is 2 to the 2nd power times 5 to the 2nd power. And this is going to help us with the GCF. And 36 is 6 times 6. And each of the 6's is 3 times 2. Circle your primes. And you've got 2 squared times 3 squared. Now we ask ourselves, what's the GCF? Well, the blue, 32, I got 2 to the 5th. The green, I got 2 to the 2nd, and the red, I got 2 to the 2nd. So the largest GCF there is going to be 2 to the 2nd power, which is 4. And then 5 squared in the green, the 100, but I don't have 5s anywhere else. And the 36 has a 3 squared, but I don't have the 3s anywhere else. So the GCF is 4. Oh, got to do the variables too. So that's the number portion. Let's do the variables. I got x cubed, x to the 2nd, x to the 1st. GCF, the smallest exponent, x to the 1st. Now I divide it out. So I've got 32 divided by 4. That's just 8. X to the 3rd divided by x, that's going to be x to the 2nd power. All right? Plus 100 divided by 4 is 25. X to the 2nd, and I pull out x to the 1st, I'm left with just x. 36 divided by 4 is just 9. And I had 1x, I pull out the 1x, I'm left with no more x's. And there's my final answer. Okay? So now that you've seen the video, go ahead and try the practice worksheet that goes along with the GCF factoring, and good luck.